Okay, guys, for our quiz tomorrow, there's a couple rules that we're going to have to remember and familiarize ourselves with again. The first thing is where are we shifting, because that's going to be really important. So we have to remember, okay, and I would write this down in study, that if you add on the inside, okay, that is a shift to the left. If you are subtracting on the inside, that is a shift to the right. If you are adding on the outside, that is a shift up. And if you are subtracting on the outside, that is a shift down. Shift, there we go, down. Okay, you also need to be aware of a couple properties of exponential and logarithmic functions. So for y equals e to the x, if you were to look at an x and y axis and then the graph, okay, first of all, there is a horizontal asymptote for y equals e to the x. That's at y equals 0. And that graph, generally speaking, looks like this, okay, because it's an exponential function. The domain is all real numbers. And then the range, okay, is y greater than 0. But for y equals log base a of x, and that could be natural log, it could be log base 2, whatever it is, okay, that's a little bit different. That's the inverse of the exponential function. So now we have a vertical asymptote at x equals 0, and that graph starts here and goes out like that. So we need to remember these two general shapes. Also remember that for the domain of, the domain of the log function, x is greater than 0, and for the range, it's all real numbers. And I know you might get a little confused, and it might be tricky to remember which one is which, but you have to do your best, okay? Exponential, domain is all real numbers, range is y greater than 0. Logarithmic, x is greater than 0, range is all real numbers. The last thing we need to know is for compounded interest. If it's compounded, and remember the key word is continuously, a is going to equal p times e raised to the rt. Okay? So tomorrow what you're going to need to do is you're going to immediately need to come in, you're going to need to grab your graphing calculator, which I'm going to get right now because you're going to be using that a lot. Okay? Alright, so now that we have that, we're ready to go, and let's get started with our practice quiz. Now the first thing we're doing here is log base 10 of 1 over 10,000 is equal to -4. Okay, and it says rewrite each equation in exponential form. So remember, 10 is your base, -4 is the exponent, and this is the answer right there, 1 over 10,000. And you're done. So over here, log base 6 of 216 is equal to x. 6 is the base, x is your exponent, and 216 is your answer. Log of 5 is equal to x. Now I don't see a base written here. So if you don't see a base written, remember that is base 10. So this is 10 is your base, x is the exponent, and 5 is the answer. And then over here, natural log has base e. And so this is e raised to the m is equal to 7. Okay, you're going to need to be able to do those. Now this is what I like a lot. Log base 3 of 81. Again, it's asking you what is your exponent. And log base 3 of 81 is equal to 4. And that's because 3 to the 4th is 81. But this is the answer there. That's the only number you have to write down. Log base 23 of 1 is equal to 0, because again, 23 to the 0 power is equal to 1. This is your answer though. You don't have to write the 23 to the 0 as 1. I'm just writing that down there so you can see. Log, I don't see a base right here, so we assume it's base 10. So 10 to what power is equal to 100? That's going to be 2. Because once again, 10 squared is 100. Now this is the tricky one here. Log base 9 of 3. Okay, I'm going to scoot over here and rewrite that. Log base 9 of 3 equals. Well, I've got to think, 9 to what power is equal to 3? And what I know is that the square root of 9 is equal to 3. Okay, so I got to think what exponent is the square root, and that's 1/2. 9 to the 1/2 is equal to 3, so log base 9 of 3 is 1/2. So let's do another example like that. Let's look at log base 5. No, excuse me. Let me do that. That was a bad number to choose. There we go. Let's do log base 36 of 6. You got to think to yourself, okay, 36 to what power is equal to 6? And well, we know, okay, that the square root of 36 is equal to 6. And this right here is the 1/2 power. So this is equal to 1/2. So over here, when it says log base 9 of 3, again, that is equal to 1/2, and that is because 9 to the 1/2 is equal to 3. Log base 6 of 1/6, that's equal to -1, because 6 to the negative first is equal to 1 over 6 to the positive first. And then the natural log of e. Remember, this is log base e, so e to what power is e? And that's 1. Because e to the first is equal to e. Okay, over here, remember that exponential functions and logarithmic functions, as long as these numbers are the same, they're inverses of each other. So the 11 and the log base 11 cancel, we're just left with x. Similarly, log base 3 and 3 cross out, we're just left with x. Natural log of e, gone, gone, just left with x. And e to the natural log, same deal, we're just left with x. Okay, simplify each expression. We have e to the x, e to the -3x, e to the 5th. You have to think about what to do with your exponents. And since we're multiplying here, we're going to add all those exponents up. So we'll do x plus -3x plus 5. And that equals e. X plus -3x is -2x plus 5. And that's all we can do because these are unlike terms. So we'll box that up. 6e to the 3x. I'm going to write this in case you don't have the hard copy here. This is 6e to the 3x over 4e. And so first of all, I'm looking straight down there. I see 6 over 4. That's a fraction that will reduce to 3/2. And then I got to think, okay, I have an e over an e. I got to think about what to do with those exponents. And so that'll be e. I need to subtract. Keep in mind that the exponent here is 1. So it'll be 3x minus 1. And you're done there. Because 3x minus 1 are unlike terms. This right here, in case you can't see it, says the cubed root of 64e to the 9x. If you recall, every exponent in here has to match the index. So this will be the cubed root of, and 64 is really 4 raised to the 3rd. And then e to the 9x, I really need it to be an e to the 3rd. So what times 3 is 9x? That'd be a 3x. And so the cube root and the cubes cancel. We're just left with 4e to the 3x power. Here, everything inside the parentheses wants the power of -1. So the 3 is going to get a power of -1. and the e to the negative 3x gets a power of negative 1. Now right here, remember, you want to multiply your exponents. So that's 3 to the negative first. E to the negative 3x times negative 1 is positive 3x. And then this guy wants to move to the bottom. This one is going to stay. E to the 3x over 3. Here it says you deposit $1,000 into an account to save money for a car. The bank pays 7.4% interest. If you neither deposit or withdraw any money, you're not putting any more money in, you're not taking any out. How much money to the nearest cent will be in the account 6 years? That should be in the account 6 years later, if the interest is compounded continuously. And that's why we needed the A part. Okay, compounded continuously means A equals P times E raised to the RT. So we're depositing 1,000, that's our P, times E. Our rate is right here, 7.4%. But you have to turn that into a decimal. So take the decimal and move it twice to the left. So that's going to be 0.074. And then T is going to be, how many years are we leaving it in there? It says 6 years, so we'll multiply by 6. And this I'm going to have to type into my calculator. We'll do, again, it was 1,000 times E. So I push the second button and then the natural log button. It already has my caret, 0.074. And then we multiply by 6. Close the parentheses, hit enter, and there we go. Now it says round to the nearest cent, so I'm looking at the 3, look behind, it's a 0, I don't round the 3 up, it's 1,558.93. 1,558.93. Now we have to do the domain and range of each function. Okay, and this is where it's going to come into play that we have to remember vanilla exponential and vanilla log. This is an exponential function here. Okay? Now typically for exponential functions, we can go back and look. For our exponentials, domain is all real numbers, y is greater than 0. Okay? So in this case, we're an exponential. We are shifting. We're shifting left 2 and down 3. Domain's not going to change for exponential since it's all real numbers. But because we're shifting down 3, the range, which was y greater than 0, also goes down 3. And so that becomes y greater than negative 3. For number 21, again, an exponential function, domain is all real numbers. The range, once again, we're subtracting 3 here. I wish I had chosen a different number. Should have made that a plus. Let's make that a plus right here, okay, just to make it a little bit different. And since we're adding 3 on the outside, y is going to be greater than positive 3. Now logs are different. Come back and let's check out the domain and range of logs. For a logarithmic function, domain is x greater than 0, range is all real numbers. So here, when we do our domain, okay, typically for logs, x would be greater than 0. But because of this, we're shifting 4 units right. That's subtracting on the inside, that shifts 4 units right. So therefore, x is greater than 4. Range for logs never changes. All real, and I'm just going to shorten numbers to be the number symbol. Over here, domain, since we're shifting left, adding on the inside shifts left, domain becomes x greater than negative 1, and then the range, once again, does not change, all real numbers. So I'm going to stop the video here, and I'm going to make a second part for the second page.